Okay, following presenter is Dr. Haijian Li. Dr. Haijian Li is Associate Professor with the College of the Metropolitan Train Station, Beijing University of Technology. Dr. Li will present his work titled Development and Application of Connected Vehicle Technology Test Platform Based on Driving Simulator, Case Study. Dr. Li, can you please make it a full screen and start your presentation?
Hello, Jane. Can you see the screen?
Yes, but it seems like a last slide.
Okay, I'll get started. Sorry. Hello, everyone. I'm Haijian Li from Beijing University of Technology. It's my great pleasure to share the research work of my team on development and application of connected vehicle technology. Here we will show some case study based on driving simulator. I will make the speech on 5 parts. The first is the introduction of this work. Second is the research framework. Then case study on the fog zone scenario, the tunnel zone scenario, and work zone scenario will be shown. The fourth is discussion, and last is the conclusion. The study goal is to provide a case reference for CV technology testing. Then our method is based on driving simulator. Using the driving simulator, we built a CV environment for fog zone, tunnel zone, and work zone respectively. The results and the contribution are positive, we think. We hope the study can provide a reference for researchers in related fields. As we all know, currently it has been a hotspot to solve traffic problems with CV technology, and many countries are conducting connected vehicle research now. In 2019, the outline of building China into a country with strong transportation network point out that the research and the development of intelligent vehicles should be strengthened. So it has attracted much attention to apply the CV technology to strengthening traffic safety. The study of CV technology from theory to practice demands various interactions and test stages, from system design to performance test, then simulation test. At last, it will be field test. It's a long journey, we think. The safety testing of CV technology can be carried out in a variety of methods, which is necessary for the theoretical analysis as well as practical applications. This is our common understanding, I think. Driving behavior and safety can be improved effectively through the CV technology. As a tool to study driving behavior, driving simulators are widely used in human factors research and have been proven effective. The human factors must be considered in the testing process. As we know, among the driving behaviors that affect safety, responding behavior, visual behaviors, speech control, and lane changing are fairly representative. Meanwhile, we make a research relationship diagram based on driving simulator. The driving simulation technology has become the mainstream of human factor tests in the CV environment. It has several other advantages, such as affordability, real-time data acquisition, controllable events, human-machine in-loop test. At present, the influence mechanism of CV technology on driving behavior and safety in different scenarios is not yet clear, which impeding the design and improvement of CV technology at the macro level. So we design a systematic framework of driving simulation experience for CV technology. And the three typical cases, fog zone, tunnel zone, work zone, are selected for verification and analysis. Okay, let's go to part 2, research framework. As you can see, part 1 is platform development. Part 1 is to solve the problem, how to build a connected vehicle system. Part 2 and part 3 are scenario design and experiment design. After the experiments, we go to part 4, data collection. Part 5 is the influence analysis, which includes adaptations analysis and traffic flow analysis. Last is comprehensive evaluation. Here we go to case study. Firstly, how to develop a platform in a connected vehicle environment. As we can see, the platform consists of 4 parts. 1 is driving simulation system. 2 is HMI, which is human machine interface device. 3 is eye tracking system. 4 is data processing center. We use several key technologies to connect them. The platform has positive scalability, and the following key technologies are used in the development process. 1 is API, another is UDP, and the third is Wi-Fi. This page shows the HMI and the eye tracking system. The HMI is designed based on Huawei Pad. The interface looks like this. The left 2 pictures. A kind of eye tracking system is used to record eye movement data, the red picture. Okay, I think the important process is scenario design. We select 3 typical scenarios, fog zone, tunnel zone, work zone for freeway applications. The experience is divided into CV state. We also call the CV state or with HMI, and normal state. We also call non-CV state or without HMI. This page shows the scenarios in a fog zone. It includes 3 segments, which are clear zone, warning zone, and heavy fog zone. We have 5 points, warning points in warning zone. This slide shows the other 2 scenarios, tunnel zone and work zone. They both include transition zone and warning zone. As we can see, the necessary traffic signs and markings are shown in suitable areas. Here is the participants in this study. The participants are chosen from the group of the designated drivers, professional drivers, and college students who have driver license. The distribution of the participants' characters is generally consistent with that of driver nationwide. In general, 43 persons participate the fog zone experiment, and 37 persons take another experiment, which contains the work zone and tunnel zone. The table shows the experiment procedure. It contains 5 steps. The first step and the last step are both related to subjective questionnaire. The results of the questionnaire indicate that drivers are in fine condition after the experiment. Step 2 to 4 are the driving practice and formal experiments. The driving time is less than 25 minutes each time. These 3 videos are time segments. They show an experiment fragment of tunnel zone. Let's wait for a while. Okay, let's go on. Here is the result. For fog zone scenario, we analyze the visual behavior, the area deviation, and the indicator selection is as follows. The left picture shows the fraction points in the divided area. As shown in the red table, 4 indicators are selected which are driving time, the frequency of fixation outside the area of interest, attended area, and attended area per unit time. The left video shows the eye movement. Attendee algorithm can show the level of visual distraction. Please look at the red picture. The sum of the difference between attendee area and attendee buffer represents the degree of influence of distraction task on visual distraction. Please wait a minute. Okay, let's go on. For the indicator, the frequency of fixation outside the area of interest, as shown in the picture, HMI has a significant impact on the driver's distraction. The indicator attendee area and attendee area per unit time in the 2 pictures, we have the HMI can significantly aggravate driver's visual distraction. Then we built the index system of driving behavior in fog zone. The index system includes safety-related indexes and compliance indexes, in which we select 3 representative indicators of speed safety entropy, speed follow ratio, and deceleration rate of 5 warning points. In the warning zone, the speed safety entropy of the CV state and the non-CV state is significant. In the CV state, the driver's speed following ratio is relatively small. Then we have that the speed following degree is better in the CV state. For deceleration rate of 5 points, the driver has a higher degree of compliance to the HMI warning information of 0.1 and 0.5. From this page, we go to tunnel zone scenario. An index system of tunnel zone is shown in the table. 2 representative indicators, speed and speed variable coefficients, are selected in this paper. As shown in this picture, when the HMI is on, it has a positive effect on decreasing the speed earlier. Meanwhile, another result revolved that the early warning is benefit to speed adjustment when approaching a tunnel. Let's talk about the last scenario, a walk zone. Here is the index system of walk zone in this paper. 2 typical indicators of speed and acceleration were selected from the speed control level. Cumulative lane changing impact area was selected from the lane changing control level. For speed index, in this picture, we have that the position of the speed peak with HMI appears in advance. It shows that the HMI has enhanced the driver's speed control ability. For acceleration index, we can draw a same conclusion, I think. The HMI has enhanced the driver's speed control ability. For cumulative lane changing impact area, please look at this picture. The impact area of CV state is about 19% less than non-CV state. A front and lower cumulative lane changing impact area is conducive to the improvement of safety. Here we give the conclusion. Please look at these current study areas. The study results of this paper are consistent with exceeding research, we think. Here we draw a special temporal trajectory of each person for tunnel zone and work zone from a special distribution of capacity. These pictures show some results on traffic efficiency with HMI and without HMI using the same data of the tunnel zone and work zone scenario. And here are some detailed results. In the tunnel zone and work zone scenarios, we want to point out that the driving simulator can also analyze traffic efficiency in addition to traffic safety. Last, let's make a conclusion. Firstly, the comprehensive safety test platform of CV system was constructed based on the driving simulator. Then for fog warning system, it promotes the safety awareness of drivers who have a high degree of compliance. But the information provided by the fog warning system will distract drivers' attention. In a tunnel zone, CV technology enhances driver's ability and equals them smoother operation, thus enhance safety, I think. In the work zone, CV technology improved the driver's ability of control speed and lane changing. Conclusions can be drawn. One, the solution offers a reference for the test of the connected vehicle technology. Two, the development of CV technology test platform is productable. Three, the case study enrich and optimize connected vehicle technology for future applications. What's more, the future research will be focused on abundant scenario and evaluation indicators. Okay, that's all about our study work on CV test. Thank you for your attention.
Okay, thank you very much, Dr. Lee. And I received several questions, not for the system, but one of my students sent me a personal message about the your study. Mm-hmm. Have you tried the have you tried to consider the lane changing behavior inside tunnel and speeding performance after exiting the tunnel, and the driver's behavior and performance while passing through tunnel groups can be also considered? But did you have any chance to consider those things in your study?
Okay, I think it's good questions, but I need several time to answer this. Please allow me to type the answers after the presentation.
Okay, I'll let the students post the question. Okay, thank you very much. Dr. Lee.
Thank you.
Okay.
Thank you.
Thank you very much.